Everything sciencey we do best. Missy helps you pass the test. Whee!
Hello and welcome to the how-to series of science videos with me, Ms. C. In these videos, we will tackle the topics which at the moment make your brain hurt and make them a little less painful. In this video, we're going to focus on problems or solving problems which include gases. So what do I mean by this? Okay, so let's have a look what this is all about. So, at the same temperature and pressure, equal numbers of moles of any gas will occupy the same volume. At room temperature and pressure, that's what RTP stands for, 1 mole of any gas occupies a volume of 24 decimeters cubed. And remember, decimeters cubed is just another unit of volume. So make sure you learn this fact because it is going to be very useful. So how do we do these problems? Well, we have a lovely formula which we can help us to solve these problems. So the volume of a gas is equal to the mass of the gas in grams divided by its formula, mass, multiplied by 24. So again, a key formula for you to learn. So let's have a look at a worked example. And guess what? We're going to use the formula. So, what is the volume of 219.5 grams of nitrogen at room temperature and pressure? The formula mass for nitrogen is 28. So, we're going to plug our numbers into the formula. So you can see we've got 29, no we haven't, we've got 219.5 divided by 28, because that's the formula mass of nitrogen. Multiply that by 24, and it gives us a volume of 188.1 decimeters cubed. So it's as easy as that. Let's have a look at another worked example. So we've got to find the volume of hydrogen gas that reacts with 200 centimetres cubed of nitrogen gas measured at the same temperature and pressure. And we are given the balance symbol equation. Now, this question, solving it, is not as difficult as it looks. Let's just look at the mole ratio of the reactants. And you can see from the coefficients that we've got a mole ratio of nitrogen to hydrogen of 1 to 3. So you can see that 1 mole of nitrogen reacts with 3 moles of hydrogen. In the question, you're already given the volume of nitrogen gas, so you just multiply this amount by 3 to get the amount of hydrogen gas required. So 200 centimetres cubed times 3 equals 600 centimetres cubed. Boom! Another easy peasy question solved. Let's have a look at another worked example. Find the volume of carbon dioxide gas formed at room temperature and pressure when 10.0 grams of propane burned in oxygen. And again, you're given the balance symbol equation. Okay, don't panic. This is not as tricky as it looks. So I've said this before, if in doubt, always work out moles and you'll be able to pick up some marks. So we're going to start off by working out the number of moles of propane. We've got the formula mass of propane, okay, which is 44. So to work out the moles, all you do is divide 10 grams, the mass of propane, by its formula mass, and we get 0.227 moles. So by now, you should be able to work out moles in your sleep. So next, we've got to work out the number of moles of carbon dioxide. So we use the same formula. Moles is equal to mass divided by formula mass. Okay, so in this particular example, if we look at the ratio, the mole ratio in the balance symbol equation, we can see that 1 mole of propane produces 3 moles of carbon dioxide. So therefore, because we don't have a mass of carbon dioxide, we can actually use that mole ratio to give us the actual number of moles of carbon dioxide. So all we do is multiply 0.227 by 3, and that gives us the moles of carbon dioxide, which is 0.681 moles. Now, we've got to work out the volume of carbon dioxide produced. So we've got the number of moles of carbon dioxide, and all we do is times it by 24. And when we do that, we end up with 16.4 decimeters cubed. Woohoo! You did it! So let's have a look at another worked example. So this time we've got to find the mass of potassium fluoride formed when 120 centimetres cubed of fluorine gas at room temperature and pressure reacts completely with potassium. So here in the question, we are given the balance symbol equation. So how do we solve this kind of problem? Don't panic, be kind to your mind, and let's do what I mentioned before, work out the number of moles. So the number of moles of fluorine, which is one of the reactants, we have got 120 and we divide it by 24,000. So 24,000 is the volume expressed, so the mole of one volume of gas expressed in centimetres cubed rather than decimeters cubed. So we can work out the moles of fluorine to be 0.00500 moles. So next, we're going to work out the number of moles of the product, potassium fluoride. So let's look at the mole ratio in the balance symbol equation. Potassium to potassium fluoride, the mole ratio is 1 to 2. So all we need to do is multiply the number of moles that we just calculated by 2, and that gives us the moles of product, potassium fluoride. And we've got the moles of fluorine, as we've already calculated. Now, next step, we've got to work out the mass of the product formed. So mass is equal to moles multiplied by the formula mass. And formula mass for potassium fluoride is 58. So we just multiply that by the number of moles of potassium fluoride we've just calculated. And that gives us a mass of potassium fluoride of 0.580 grams. So, again, no panicking involved, just working through the simple steps, and voila, you arrive at the correct answer. So you can do this, you've just got to take one step at a time. So I hope you found this video useful. If you have, please give it a thumbs up and hit subscribe so you will be notified when more videos are added. If there are any other calculations in biology, chemistry or physics which make your head hurt, please pop them into the comments box and you may see your request turned into a how-to video very soon.
All things sciencey, we do best. Miss C helps you pass the test. Whee!